Okay, so I think let's get started. So welcome to join our tutorial. Today we will discuss about deep learning for recommendations. We will focus on some fundamental deep learning technologies for recommendations, and also we will discuss recent advances in deep recommender systems. So my name is Jiliang Tang. I'm from Michigan State University. I will co-present this tutorial with Wenqi Fan from Hong Kong Poly University and Shanyu from City Hong Kong University and Da Wei from Baidu. So here we have the tutorial website shown at the bottom, and also we shared the link in the chat room. We will upload the slides into this website. If you are interested, you can remember this link, and you can download all the materials in this tutorial website. So for the audience, please mute your audio. And if you have any questions, there are two forms you can raise your question. So the first, so the first form is you can type your questions into the chat room. I think our presenters, when we are available, we will answer your questions. And the second way is we will have a break. If you want to have some face-to-face interactions, you can ask the questions during the break or by the end of the tutorial. Okay. So as we know, right, with the advances of technologies such as the mobile phones and the social media, information is increasing exponentially. If you look at the sky, there are so many stars in the physical universal. Do you know in 2013, we have as many bits in the digital universal as stars in the physical universal? I believe now the number is much more than the stars in the physical universal. On the other hand, information is increasing exponentially. With so much information, now it becomes very hard for us to locate the information we want. That means we are overloaded by the rich information. How to solve the information overloading problem? Typically, I think there are two major techniques. So one is we know it's information retrieval. So when you give the query, of course, at such scenario, you need to know your own information need, and you form your information need as queries, and then you can query from the modern search engine, such as Google, Baidu. Of course, in these vertical websites like YouTube, you also can use the search. They typically provide the search interface for you to get the information you want. Another way is today our today's top focus, recommendation. So for recommendation, you don't need to specify your information need as queries. The system will learn your preferences through your historical data in the website, and then they will recommend the items which have the potentials to interest you. For example, here, when we say items, could be any content in the website or in the online world, such as products, news, movies, videos, friends, and so on. Indeed, recommender systems are everywhere in the online world. So when you open a browser and you type the URL to a website, we can see the recommender systems there. So let me give you several examples. So the first example is from the e-commerce, such as Amazon, eBay. Of course, in China, we have Taobao and JD.com. When you open, no matter you use your you use your cell phone or use your PC or laptop, or when you browser into such website, you can see those kind of recommendations. I believe this example is from Amazon. So this will so if you browse the book A, so they will show you B and C because they are frequently brought together by others. And another example is from the content sharing website, especially like this news. And I believe recently it's very hard for this kind of TikTok and YouTube. So this kind of video sharing website. Again, when you enter into those web services, you will get their information. You sometimes on the first page you can see those videos, and you can say, oh, why they can match my interests so well, right? So I think the hero behind this is recommender systems. And I think so probably a few months ago, the MIT Technology Review, they got the most impressive technologies in last year. I think the recommender system of TikTok is one of them. Okay, and another example, in addition to recommend this kind of products, content, we also can recommend people in their online world, like in this kind of social networking or social media, such as Facebook, LinkedIn, and in China we have the Weibo. So typically for those websites, typically you will get something like this. So they will recommend you some potential friends you want to connect. Okay, so all those examples showing the importance of recommender systems, and also somehow with the recommender system, it can increase the user engagement because it's easy for us to get the information we want. And also in some scenarios, for example, in TikTok, so you can spend hours on TikTok. It's because the algorithms can always recommend something you are interested in, and then you will stick to those kind of content recommended. Okay, so here I want to, through this example, I want to show what's the typical setting of a recommender system. So here the example is from the moving recommender system, like the movie lens, the most popular recommendation data set or benchmark. So here we have movies, we have users, right? So as soon as we have among items, we have users. Of course, here the items are movies. And users can rate their movies to indicate their preferences in each movie. For example, so here we use the 5-star rating system. So 5 means whether the highest rating, 1 is the lowest rating. Of course, in other websites, probably we don't have this kind of rating, but we have some other interactions. For example, in TikTok, right? So the items are audios or are videos, and users also, of course, are users. Probably they will click those videos, and they will comment on these videos, and so on. There are many kinds of interactions, but overall, we can have this kind of bipartite, somehow this kind of interaction graph or interactions between users and items, no matter ratings, clicks, purchases, and so on. And beyond this interactions among between users and items, in some scenarios, we also have some side information. For example, for the movies, we have some side information about the movie, like the production year, and who are the actors, and the reviewer content, and so on. On the user side, we also can have some additional information. For example, we can have their profiles, and in some cases, they even can have this kind of social relations to indicate the friendship among the users. So from this example, we can see for a typical recommender system, the input to the system typically is the historical user items. And of course, if site information is available, we will also put those site information into the system to help solve some problems all the interactions cannot solve, or we can enhance the recommender system only based on interactions. So what we want to do about the recommendation is we want to predict how likely a user would interact with a tagged item. Of course, in different scenarios, the interactions can be defined differently. For example, in the movie example, we want to predict the rating scores, but in the e-commerce, probably we want to predict whether this user is interested in this item, like the will click the item, whether view the item, whether purchase those items. So in different scenarios, we can have different definitions about interaction. But the overall goal for a recommender system is we try to predict more interactions, potential interactions. Okay, so one popular technique to achieve this goal is collaborative filtering. So basically, the basic assumption of collaborative filtering is similar users will have similar preferences. So that's why we can base them on their historical data to get similar users. And then in the future, we can use this kind of similarity or similar users to make the recommendations. So the important step for a system based on CF is how can we model user preferences based on their past interactions. Okay, so one typical way is how can we encode their preferences? One typical way is we want to learn their representations. So in such a way, the representations can encode their preferences information, and then we can calculate their similarities, or we can do some other scoring functions based on their preferences or representations to learn to do the prediction. So here, we still use the move length example to illustrate. So basically, the previous interaction data set, we can deload it as a user item matrix, right? So in this matrix, we have a lot of missing values, basically for those movies, because typically we can only watch a few movies, while in the movie recommender system, we have millions of movies. So in this way, in this user item matrix, actually, this matrix is very sparse. A lot of entities are unknown. It is the task we try to predict. So what we want to do is we can learn representations of items and users based on those observed entities in the matrix. So once we learn the representations, we can make a further prediction for the future. So here, of course, one assumption we have is those representations can encode user preference information. So one popular technique to achieve this goal is matrix factorization, because we mentioned that naturally the user item interactions can be deloaded as a matrix, and there are a lot of missing values in this matrix. So naturally, we can consider this representation learning problem as a matrix completion problem, right? So we just want to complete the entities in this user item matrix. So what we will do is we will learn the user representations, and we learn the item representations, and of course the dimension. So the dimension of the latent space is typically D. So D is typically much smaller than the number of users and the number of items. So once we learn, because we somehow project the users and items in the same latent space, so in this way, we can use the inner product, or somehow this is some kind of measurement of similarity to predict the ratings I and J. So once we learn the representations on PI and PJ, we can use the inner product to predict the ratings, or whether the likelihood of existing interaction between them. So the next question is, how can we learn those representations? Although we have this kind of philosophy, but we need some objective function to learn PI and QJ. So basically, it's quite straightforward. Basically, we observed there are some observations on this matrix, and also in the previous slides we show once we have PI and PJ, how can we model the interaction between them? So basically, in this way, we just minimize the observations and the predictions for those pairs we already observed. So in this way, we can learn PI and PJ simultaneously. After we learn PI and PJ, and then we can, if for example, so in this case, the item user one, if we want to predict what's the rating score between user one and item three, we can use P1 and in the product of P1 and Q3 to indicate the score for in case we want to make the predictions. Okay, so we can say, as we mentioned, so for this collaborative filtering algorithms, learning representations is the key for its success. When we mention the representation learning, probably the first terminology in your mind is deep learning, right? So indeed, we allow in the area of deep learning because of its promising performance. For example, so here we show in some areas, deep learning has greatly advanced their quite a few or quite a lot of tasks in those areas. So one area is the computer vision. Here, I believe a lot of you should know this example. So in the image data set, we want to do the image recognition, right? So when we use the deep learning technologies, we can see the image recognition error continuously decrease. In this particular data set, in this particular, task, so the deep learning models can even achieve better performance than human. And of course, we can easily to give a lot of more examples. For example, in the speech recognition, in natural language processing, and some famous example probably you get. So you know the AlphaGo, right? So the computer, the AI agent can beat the champion in the game of Go. And indeed, deep learning has brought a lot of advances in quite a lot of fields or areas. So a larger question here we definitely have is because how can we extend the success of deep learning into recommended system? Yes. The answer is yes. So that's why recently there are so many algorithms emerging to apply deep learning in recommended system. That's also the focus of this tutorial. So in the following tutorial, we will first discuss about the fundamentals of deep recommended systems. So basically, we will introduce some basic algorithms for deep recommended systems. And then we will focus on the three advanced fields. So one is how can we use reinforcement learning to help recommend the system? And then how can we, because the user item interactions can be represented as a bipartite graph, right? And also for the site information we introduced before, for the item information, we can deload the item site information as a logic graph. It's also a graph. And then we can deload the site information of users, like the social networks, also as a graph. So that's why it's naturally we can use the graph-based techniques to advance recommender system. So that's why they are increasing attention in applying graph neural networks in recommender systems. And of course, because the complexity of deep learning models is we need a lot of efforts to tune the algorithm to decide the architectures. So can we use the automated machine learning to automate this process? In this way, we can search the optimal architectures, the optimal models for a given recommended task, finally, we also will discuss some dark side of deep learning based recommender system. Here, because given the limited of time, we only discuss the safety of recommender system. Basically, we can use some techniques to perform adversarial attacks on recommender systems to promote the items or the content we want to promote. Okay, of course. So there are many aspects of dark sides of deep recommender systems. So in the following conclusion part, I think we will discuss more those aspects. Okay, and so here is a brief agenda for the following tutorial. So Wenqi will discuss about the fundamentals, and then Xiangyu will discuss about how can we use deep reinforcement learning for recommender system, and then we will take a break. And during this stage, we can have some interactions to discuss some questions if you have. And after the break, we will go back to Wenqi for the Jiliang's world recommendation, and then Xiangyu will discuss automated recommender system. After that, Wenqi will discuss one dark side of deep recommender system about adversarial attacks. So in the conclusion part, Wenqi will discuss more those dark sides of deep recommender system. Okay, so that's pretty much about a brief introduction about our tutorial and also the topics we will cover during for this tutorial. I will hand over the tutorial to Wenqi. Thank you.